Hello, my name is William Hoffman, and this is a set of problems involving the simplification of complex fractions. I hope that you find it useful for you in your studies. Good luck. Simplification of the complex fraction x divided by x minus xy over z. One of the rules that we need to know in order to solve this problem is that a divided by b plus c divided by d, these are representations of fractions, equals ad plus cb over bd. And the reason why we need to know how to add two fractions together which have different denominators is because if you look and see right here in the denominator of the complex denominator of the complex fraction, the value x does not share the same denominator with the value xy over z. Now, let me show you this rule worked out with the example 1/3 plus 1/4 equals 1/3 times 4 over 4 plus 1/4 times 3 over 3 equals 4 over 12 plus 3 over 12 equals 4 plus 3 over 12. You can see AD plus CB over BD, when you substitute these values in right here, this end result right here. 4 is AD, or A is 1, and D is 4, that's 4. The 3 is the CB. C is 1, B is 3, there. And BD, 3 times 4 equals 12, which gives us the answer of 7/12. But we weren't really looking for the answer. What I really wanted to show you was simply how this works. Now that we know how it works, let's see if we can apply it. X over 1 minus xy over z. So we're going to multiply xy over z by the denominator, which is 1. And we're going to multiply x over 1 by the denominator over here, which is z. And it's going to give us x over xz over z minus xy over z. Now, another one of the realities when dealing with fractions is that if you have a over b plus c over b, it's the same as saying a plus c over b. And right here, this is xz over z, this is xy over z. In other words, we can represent it in this fashion. Now, we're subtracting, but subtraction is the same as addition of a negative value, so the rules apply. So what we actually have is x over xz minus xy divided by z. Now we need to take a look at another rule. If you have the values a over b over c, it's the same as saying a times c over b. In other words, 2 divided by 3 divided by 4 is the same as 2 times 4 over 3. It's not important to work it out, but I'm just trying to show you that this is going to be your answer. You can work it out another way, but this is the algebraic way of solving a fraction. You simply take the denominator, or the value in the denominator, flip it, which gives you the reciprocal, and multiply. That's important because A over B over C is sort of what you have right here. So let's go ahead, and using what we know, we can represent this as x times the denominator's here, so we're going to flip that over, z over xz minus xy. And that gives us xz over xz minus xy, which is the same as saying x times z over x times z minus y. And when you have a value and you're multiplying it by some value and dividing it by some value, as we are multiplying this by x and dividing it by x, it doesn't actually change the value at all. So the x can be eliminated, yielding z over z minus y. As a simplified form of the complex fraction, x over x minus xy divided by z. Our second complex fraction is 1 minus 1 divided by x squared over 1 minus 1 over x. Multiplying the value 1 in the numerator, or the complex numerator, by the denominator of the fraction 1 over x squared, and the 1 in the complex denominator of the complex fraction by the x value of the denominator of the fraction there, gives us this: x squared minus 1 over x squared divided by x minus 1 divided by x, which is the same thing as x minus 1 times x plus 1 over x squared divided by x minus 1 divided by x. A over b over c equals a times c over b, but a over b over c over d equals ab times dc. So this here is equivalent to being rewritten in the following fashion: x minus 1 times x plus 1 divided by x squared times x over x minus 1. And now we can start eliminating some of the common factors. And the x squared is the same as x times x, so we can basically get rid of this, and we're just left with 1x down here, which means we have x plus 1 over x as our solution. Our next problem is a simplification of the complex fraction a over a minus b minus a over a plus b all over b over a minus b plus a over a plus b. Now, in order to yield a common denominator for the values in the complex numerator here, I'm going to multiply a over a minus b by a plus b, which is the value of the denominator of its companion fraction, and the value a over a plus b by a minus b. And then in the complex denominator of this complex fraction, in order to give us a common denominator between the two elements, I'm basically going to do the same thing, multiplying b over a minus b by a plus b over a plus b, and a over a plus b by a minus b. So, it's going to look a little something like this. A times a plus b minus a times a minus b divided by a minus b times a plus b all over b times a plus b plus a times a minus b over a minus b times a plus b. Remembering our rules on division of fractions equaling multiplication by the reciprocal, we can rewrite this as a times a plus b minus a times a minus b over a minus b times a plus b times a minus b times a plus b over, I'm going to separate this out there, this is all up here, over b times a plus b plus a times a minus b. We can see that these values are going to factor out. A plus b, a plus b, a minus b, a minus b. Actually, seeing what we have here, a times a will be a squared, a times b will be ab, minus a times a, so minus a squared, minus a times negative b, so minus negative ab. A minus negative ab would yield a plus ab over b times a, which is ba, plus b times b, which is b squared, plus a times a, so that's a squared, minus ab. So, the a squared here and the negative a squared, and the a squared minus a squared, they're going to cancel out. And down here, the BA and the negative AB, I mean, AB and BA are the same thing, they cancel out. And what we have is an AB and an AB, so we have 2AB over 2AB over b squared plus a squared. And that is a simplified form of a complex fraction. Our answer is 2ab over b squared plus a squared. Our next problem is the simplification of the complex fraction 1 plus 1 over 2m divided by m minus 1 over 4m. You might be able to look at this and just immediately know that what you're going to have is 2m plus 1 over 2m over 4m squared over 4m squared minus 1 over 4m. Or maybe not. But even if you're not quite there yet, you will be if you just repetitiously do enough of these problems. It goes like this. 1 is the same as 1 over 1. We want to have a common denominator with the other fraction.
So we can multiply it by 2m over 2m and add that to 1 over 2m. It's all over m over 1 times 4m over 4m minus 1 over 4m, which gives us 2m plus 1 over 2m divided by 4m squared minus 1 over 4m. And we know that division of fractions is equivalent to multiplication by the reciprocal, so we can rewrite this as 2m plus 1 over 2m multiplied by 4m divided by 4m squared minus 1. We can cancel out the factors m, and we can reduce the 4 over 2 to just 2 over 1. And we are then left with 2 times 2m plus 1 over 4m squared minus 1. But if you look closely, you'll see that the value 4m squared minus 1 can be represented as the difference of squares. So what we actually have is 2 times 2m plus 1 over 2m minus 1 times 2m plus 1. So we can further reduce these two factors, and our simplified form is 2 over 2m minus 1. And if you're like me, you'll have a problem with it being written like that. So, write that one more time. 2 over 2m minus 1, the simplified form of a complex fraction. Simplification of the complex fraction 1 divided by a minus a all over 1 plus a. We can rewrite 1 over a as, well, actually we don't need to rewrite that one. It already has the denominator. We're going to change the second value to match. 1 over a we'll simply write down minus a times a over a, all divided by 1 plus a. We multiply a by a over a so that it'll have a common denominator with the other value, and we're left with 1 over a minus a squared over a, all divided by 1 plus a, which is equivalent to 1 minus a squared over a divided by 1 plus a, which is equal to 1 minus a times 1 plus a divided by a divided by 1 plus a, which is equivalent to being rewritten as 1 minus a times 1 plus a divided by a multiplied by 1 over 1 plus a. These values cancel, and we're left with 1 minus a over a. And that's the answer, the simplified form of our complex fraction. Our next complex fraction is the value x minus 1 over x divided by x plus 1 over x plus 2. It differs from some of the complex fractions we worked on prior in that it has 3 separate values in the denominator. And if they had 3 largely different values, we might have to try and find a least common denominator, but the least common multiple will still work fine for these because x is x over 1, so its denominator value is 1, and 2 is 2 over 1, so its denominator value is 1. So in order to
have a common denominator between all three values down here, we're only going to have to do the same thing, basically, which would be to multiply x by x over x and 2 by x over x, like this. X times x over x plus 1 over x plus 2 times x over x, and then all three of these are still going to have a common denominator. Up here up top, it's x over 1 minus 1 over x, and so that's going to be times x over x, so that this will have a common denominator with this value. And we will have x squared minus 1 over x divided by x squared, I'm going to move this one over, plus 2x, moved it over here, plus 1 over x, which is equal to x squared minus 1 over x times x over x squared plus 2x plus 1. Now, we can see that the factors x are going to cancel out here, and then we have x squared minus 1 over x squared plus 2x plus 1. If you take a look at it, you probably puzzle out that x squared minus 1 is equivalent to x plus 1 times x minus 1. And x squared plus 2x plus 1 is equivalent to x plus 1 times x plus 1. Which means that we can eliminate these common factors, and we're left with x minus 1 over x plus 1 as a simplified form of our complex fraction. X minus 1 over x squared divided by 1 minus 1 over x is the same as x to the third minus 1 over x squared divided by x minus 1 over x, which is the same as x to the third minus 1 over x multiplied over x squared, multiplied by x over x minus 1. The x's, the factors of the x cancel, leaving just one x down here. And we now have x to the third minus 1 over x times x minus 1. X to the third minus 1 is the same as x to the third minus 1 to the third over x times x minus 1. This is a special case. It's known as the difference of cubes. Anytime you have a value, say a to the third minus b to the third, it can be represented as a minus b times a squared plus ab plus b squared. So, substituting x for a and 1 for b, we can rewrite this as x minus 1 times x squared plus x plus 1 over x times x minus 1. These factors cancel, and we're left with x squared plus x plus 1 over x, which is the simplified form of our complex fraction. X divided by y minus y divided by z, all divided by x divided by y plus y divided by z, can be rewritten as zx over zy minus y squared over zy divided by zx over zy plus y squared over zy.
zx minus y squared over zy divided by zx plus y squared over zy, which can be rewritten as zx minus y squared over zy times zy over zx plus y squared. These cancel, and we are left with zx minus y squared over zx plus y squared, which is the simplified form of our complex fraction. Our fraction is m divided by n minus n divided by m, all divided by m plus n squared divided by mn minus 4. First, let's group the values in the complex numerator together, and for that they'll each need to share a denominator. So, mn will multiply by m over m, while nm, or negative nm, will multiply by n over n. Meanwhile, down below, m plus n squared over mn, we won't change, but the negative 4 will multiply by mn over mn, yielding m squared minus n squared over mn over m plus n squared minus 4mn over mn, which can be rewritten m squared minus n squared divided by mn times mn over m plus n squared minus 4mn. These values cancel, and we have m squared minus n squared divided by m plus n squared minus 4mn. Goes over to give us some room. We can expand this out as m squared minus n squared over m squared plus 2mn plus n squared minus 4mn, which is m squared minus n squared over m squared minus 2mn plus n squared, which is the same as m minus n times m plus n divided by m minus n times m minus n. These values cancel, and the simplified form of the complex fraction is m plus n divided by m minus n. 1 minus 1 divided by 1 plus 1 over x is the same as 1 minus 1 over x plus 1 over x, which is the same as 1 minus 1 over x plus 1 over x, which is the same as 1 minus 1 times x over x plus 1, which is the same as 1 minus x over x plus 1, which is the same as x plus 1 over x plus 1 minus x over x plus 1, which is the same as x plus 1 minus x divided by x plus 1, which is the same as 1 over x plus 1, the simplified form of our complex fraction. The equation is x squared divided by y squared plus 1 over x, all divided by x over y squared minus 1 over y plus 1 over x. X squared over y squared will multiply by x over x, and 1 over x will multiply by y squared over y squared. x over y squared will multiply by x over x. Negative 1 over y we will multiply by xy over xy. And 1 over x we will multiply by y squared over y squared, yielding x to the third over xy squared plus y squared over xy squared divided by x squared over y squared times x minus xy over y squared times x plus y squared over y squared times x, which can be rewritten as x to the third plus y squared over x y squared over x squared minus xy plus y squared over xy squared, which can then be rewritten as x to the third plus y squared divided by xy squared times xy squared divided by x squared minus xy plus y squared. These values here will cancel, and we will have x to the third plus y squared divided by x squared minus xy plus y squared. And this is the simplified form of our complex fraction. It should be noted that this answer does not agree with that given in the back of the text. However, unless I have transcribed the original equation down incorrectly, I believe this to be the correct answer. Now, the answer that we've resolved this equation into did not agree with the answer in the rear of the text. I believe the reason why is I believe that the answer is, well, obviously the answer to a different equation. I believe that the question, problem number 11, was misprinted in the text. I believe the actual value that they had intended, instead of a 1 over the x, was for there to be a y. If we change this 1 value so that the equation reads x squared over y squared plus y over x, all divided by x over y squared minus 1 over y plus 1 over x, we will get the answer which is in the back of the text. Let's solve this equation. X squared over y squared times x over x plus y over x times y squared over y squared, all divided by x over y squared times x over x minus 1 over y times xy over xy plus 1 over x times y squared over y squared equals x to the third plus y to the third over xy squared divided by x squared minus xy plus y squared, all divided by xy squared, which is the equivalent of x to the third plus y to the third over xy squared times xy squared divided by x to the squared minus xy plus y squared. These values cancel, and we're left with x to the third plus y to the third divided by x squared minus xy plus y squared. X to the third plus y to the third falls into the special case of the sum of cubes, which can be rewritten as x plus y times x squared minus xy plus y squared, all divided by x squared minus xy plus y squared. These values cancel, and we're left with x plus y. Since this agrees with the answer in the rear of the text, I've come to the reasonable assumption that that was the equation originally intended to be solved. Simplification of the complex fraction 1 divided by 1 minus 1 over 1 plus 1 over x. It's like a recursive fraction. Alright. 1 over 1 minus 1 over x plus 1 over x is equal to 1 over 1 minus 1 over x plus 1 over x is equal to 1 over 1 minus 1 times x over x plus 1 is equal to 1 over 1 minus x over x plus 1 is equal to 1 over x plus 1 over x plus 1 minus x over x plus 1, which is equal to 1 over x plus 1 minus x over x plus 1, which is equal to 1 over 1 over x plus 1, which is equal to 1 times x plus 1 over 1, which is equal to x plus 1. Therefore, the simplified form of this complex fraction is x plus 1. Simplification of the complex fraction x plus y over y minus x plus y over x, all divided by 1 over y minus 1 over x. We'll multiply x plus y by the value of x over x. We'll multiply x plus y here over x by the value of y over y, all divided by 1 over y times x over x minus 1 over x times y over y, yielding x times x plus y minus y times x plus y divided by xy divided by x minus y over xy, which is equivalent to x times x plus y minus y times x plus y divided by xy multiplied by xy over x minus y. At this point, these values cancel out, and we have x squared plus xy minus y squared minus yx. I got these reversed here, but it's the same answer, minus y squared minus yx, all divided by x minus y, which is equivalent to x squared minus y squared over x minus y. It's x squared minus y squared over x minus y, which is the same as x plus y times x minus y, all divided by x minus y. These values cancel, and we're left with x plus y, the simplified form of our complex fraction. Our next problem is the simplification of the complex fraction y minus x plus x squared over y, all divided by x over y squared plus y over x squared. The first thing we need to do is have a common denominator for all the values in the complex numerator. So we'll multiply y by y over y. We'll multiply negative x by y over y. And we'll leave x squared alone since it's already over the value that we're changing the others so that they'll have a common denominator to match. All divided by x over y squared plus y over x squared.
In order to give each of these a common denominator with one another, we'll multiply x over y squared by x squared over x squared, and we'll multiply y over x squared by y squared over y squared. This will yield y squared minus xy plus x squared over y divided by x to the third plus y to the third over x squared y squared. This can then be rewritten as y squared minus xy plus x squared over y times x squared y squared over x to the third plus y to the third. Here the values of the y will cancel, leaving just one y. Y cancels out, and instead of y squared you just have x squared times y. So we have y squared minus xy plus x squared times x squared times y, divided by x to the third plus y to the third. X to the third plus y to the third is one of those special cases, and it can be rewritten, well, let's just move the equation down. Y squared minus xy plus x squared times x squared times y. It can be rewritten as x plus y times y squared minus xy plus x squared. These values cancel, and we're left with x squared times y divided by x plus y, the simplified form of our complex fraction.